Hello everybody and welcome to this bonus lesson. In this video I'm going to explain a simple workflow on how to create trees inside of Houdini using some of the features that ships with the game development toolset. The game development toolset is a set of HDAs that SideFX maintains and develops that comes with tons of OTLs that users can use to enhance their game production workflow inside of Houdini. And one of these nodes is called curve branches, and it allows us to recursively create curves to mimic structure like trees, cracks, and lightning. And it is not simple task to create something similar to what the speed tree offers inside of Houdini. It is a very complex task to create procedural trees, and that's why there's dedicated applications for it, especially the speed tree. And with this workflow, we're going to be able to create simple structure to mimic plants. And I'm going to show a quick setup of how it works and then explain the initial workflow. Or actually, let's start with that. So the idea is you start with a base with a line like this, and then you create the curve branch node, the game dev curve branches, and I'm gonna connect that, and I'm gonna set it to have, we'll go with 40 points for now. And you can see right away by adding this node we got these branches, and the idea is very simple. Let's increase the length and the number of curves like this. And the idea is you can copy and layer many of them, and they will recursively keep on adding more details. So the second layer, I'm gonna change the color to blue, and we can change the spread, give it some curl like this, and then we can copy it one more time, and I'm gonna change it to red. And let's reduce the length to 0.1 and the curl to 0. And you can see now we're getting a recursive structure. It's not a tree yet, but it has a main branch and then a second branch and then a trunk and branches and then leaves. And that's how this tool works. You have to create each branch, each layer by yourself. And what I've done here is I started off with a curve that I added some noise to, some bend, just to get a deformed curve. And then I started playing with the SOP curve branch settings. And the settings are quite self-explanatory. You choose the number of copies, and then the randomization, the length randomization, and you can add some noise to it that you can mask with this ramp. So this controls how much you affect the curve along its length. And so this is the first layer, and then I added another one which is called colored in red, and then a third one which is in blue, and that's it. This is what I've set together. And then I looped over each curve and created a UV attribute to represent the length of the curve. So this will be a gradient that starts black at the bottom and then white at the tip of the curve. And then I visualize this, and I'm going to use it to drive the thickness, because I want the width of the trunk or the structure to be bigger at the bottom and then thins off towards the end of the branch. And after setting this attribute, I'm calling it width, which is equal to the color that I'm setting here. I isolate each branch. So this node will create a generation attribute. The generation number 0 is the first, the second, third, and fourth, or whatever layers you have. And I separated each one of them, and I used a poly wire, and I connected the width to drive the thickness of the attribute of the branch. And I did this for all the layers, and each time I reduce the thickness so it gets smaller and smaller. So this is 220, and this is the last one, which is 400. So these are the various layers, and we can color them here actually. So we'll give this a red color or a brown color. And this will give it a different color like this. Just to get some randomization. And then I subdivided the tree to get more details, and I added another noise to it. So this is what the structure looks like. And then I isolated the last two layers. So this one, the last two branches, I isolated them. I scattered points on each one of them. This one has 10,000 points, and this one has 40,000 points. And I created a normal attribute set to direction or orientation. And you can see we have randomized normals. And then I randomized the p-scale to be between 0 to 5 and 1. And I copied this grid over. So it's just a flat grid. And I gave it a green color, which we can randomize as well. So let's create a randomize attribute, and it's going to be a color attribute. And when we copy it, those are the leaves. And I'm gonna visualize it with the tree. So this is the tree structure with the leaf copied, and obviously you can change the leaf to be high res, or you can map texture to this, and you can explore. It's really easy to work on the structure and control the properties of these curves with the branch. So I'm gonna copy all of this. I'm going to make a quick modification. So here, let's go with 60. And let's change it. This controls the offset or the aim of the curves. So I'll do something 1.2. And then this, let's lower this, something like this, and then increase the curl to have them fall down further. And then this, I'm gonna increase the curl as well. And let's increase the count here to 8. That's too much, it's curling too much here. Let's go back to 0.1. I'm gonna disable the bend I have in the beginning. And this transform. So this is a different version of that tree by just playing with the settings. So this is the structure of the branches, and this is the leaves. Cool. So that's it. Really, you then continue with the same workflow. You have a geometry and you have the leaves. You can do the same processing that James showed, and I hope you guys like this and find it useful. Thank you so much for watching, and talk to you soon. Bye bye.